Good afternoon. So today I will share a little bit about high performance computing on the mobile GPU. So I will talk about four areas. The first, I will introduce a little bit about the mobile app scenarios. And the second is some cases. We have already done three cases. And the third is about the technical challenges and the solutions during the journey of HPC. And the fourth, some future outlook and also our suggestions to the community. So the first topic, you can see this video on the right side. I won't play it due to time limit. This is on Douyin and TikTok. This is the most frequently seen scenario, and the thing is that we will download the video, and then we will do the codec, and then we will do the render, and then we will process, and then you will see the video. And of course, during the decode and render and before the render, we have this process. We want to enhance the fidelity. Sometimes we have some algorithms, and we will try to remove some noise, and we will also try to use HDR. So the process node is where we use GPU to do the computing. And this is the second scenario, also a very important scenario for Douyin and TikTok. So on the right side, this is also a video. At the bottom, you have a plus there. So you press the plus. That's the creation part. So that means this is the chain of creating content. Actually, this is what we are in charge of. And there are two pipelines here. One is the video shooting, the other is the video editing. So on the video shooting, the camera produces the video and the frames, and then we will do the enhancements, and then we will add some effects. And then there are two lines. One is on the preview, the other is going to the encoder, and then it's edited and saved to local. And on the bottom, that's the editing chain. So the user will port the video from the album, and then it goes and gets edited. So I didn't elaborate on the editing. Actually, it includes the augmentation and effects. So the three yellow boxes includes the modules with a complex algorithm. So we need HPC. Apart from the scenarios in TikTok and Douyin, we do have some other scenarios like XR, because we have Kiko. In the VR scenario, we have eye tracking, gesture recognition, and also the image video quality enhancement and so on. We will use GPU for computing. And the other is the audiovisual business. We have our own codec, and we can use the GPU to accelerate. And the last one is a new project, the camera ISP algorithm. So we can add algorithms, for example, MFSR, MFHDR, MFNR. So the super nighttime mode is based on this technology. And for those examples, actually in those scenarios, we use the GPU to do the computing to do the acceleration. And the second part is about the cases that we did. First, the on-device real-time super resolution. So this is the industry first to deploy 720p or 1080p, and this brings us a lot of value, because the value is twofold here. First, we improve the resolution. You can see the difference of the fidelity from the left to the right, and while improving the resolution, we get more time spent on the app and the user retention gets better. And of course, those two are very important KPIs for an internet company. The other thing is that we improve the bandwidth saving. So in some scenarios, we would dispatch the low resolution video and then we use the super resolution to improve the fidelity, and then we can save a lot of bandwidth cost. And we won uh, the top 10 technical innovation award in ByteDance. The other is the comic effects. Back then, the challenge was that it was the first time for us to run this kind of 2G flops model on mobile devices. And the value of this business is that, of course, we try to encourage content creation. So that content creation process is all about encouraging people to use Douyin to shoot interesting videos and post it so their friends and family can see it. So the value of this is that within 3 days of the launch of this function, more than 10 million users use this effect and submitted their work on Douyin and created a lot of hit topics. And this is really out of our expectation. So those are all videos, and this is the third case. We got the secured the return at the beginning of the year. This is on CapCut, and back then, on most of the mobile devices, we realized 720p or 1080p real-time frame compensation technology.
And if you see on the right side, you could see that with detection of the music rhythm patterns, you can have the video got automatically slowed and fasted with certain keyframes there specifically on the rhythm patterns of the music you provide. So this is an example. And the one I mentioned just earlier, the comics effect, you probably know about the GAN technology, which is deep learning, while the first and the three cases are just traditional algorithms. But our optimization are all computing on the basis of GPU technologies. And now I would like to tell you about the technical challenges we faced when engineering the algorithms, mainly coming from four aspects. The first one being performance. With limited power budget, we want to ensure to guarantee a certain frame rate and computation payloads, and together considering our the complicatedness of our algorithm, this is a big challenge. And the second thing is compatibility. Now, Douyin is used on thousands of different device types, and the lowest Android we support is version 4.x. That means a huge fragmentation in device versions, which is a big challenge for our compatibility. And the third challenge for us is stability. Douyin has an MAU of over 100 million. More than 100 million devices been running on our algorithms on those devices, but our crash ratio, according to our KPI, should be controlled below E7. And the fourth challenge is deployment, algorithm deployment efficiency. Though today I'm mentioning about the mobile and algorithm deployment, engineering, and optimization, but now ByteDance has also got some excellent PC and products like Jianyin Pro and live streaming partner. So while now, when we are speaking about those requirements, some of our products must support four different types of devices. That's why when we are designing our algorithms, we support cross-platform deployment and supports multiple application scenarios. So these deployment difficulties are the fourth challenge. Well, back to them one by one. Our performance challenges are actually separated into three parts. The first thing is that we have to fully understand that the GPU features, the ones that we use, like what we always use during optimization, frequency adjusting, image buffering, in different scenarios, and by the zero copy technology to calculating the frame rate and the memory coalescent, the faster functions, and of course, profiling tools is also something that we use so that we can analyze the kernels that we have written. Is it because of memory or cache bound or because of GPU bound? And secondly, we're going to have some algorithmic level optimization based upon our GPU feature understanding. We can make some optimizations in algorithm. For example, data rearrangement and FP16, which is widely used across the industry. We would also do simplifications of some complicated algorithms, do some simulations, which is a part of the work we do in algorithm engineering. And the third layer for that performance challenges solving is the deployment level optimizations. Because after we have made those optimization, we need to do from a more general or a macro perspective, and we use some tools, local group size, loop group size tuner, LWS tuner, so that we set up different platforms and set up different work groups. And the second one is data transfer optimization, because for audio and video application scenarios, there have the OpenGL and OpenCL related intertwining with each other, and the data zero copy or even GPU and DSP communication. The data transfer optimization actually can guarantee a large improvement in performance. That is already mentioned by the previous speakers, how the writing and the reading actually affects the performance of the application. And the next, heterogeneous parallelism. The CPU and the GPU application scenarios, we often see CPU bound or GPU bound, and now we are introducing the GSP or VPU technologies from the suppliers in order to solve the issues of those kinds. So those were the solutions of ours for the performance challenges we've faced. And for compatibility issues, we have three types of works that we have done to address that. The first one is our device cluster. Internally within our company, hundreds of devices are included. Although it doesn't cover all of the devices available in the market for using Douyin, but this cluster is already enough for us to simulate and test the compatibility and stability. And secondly, we have a device scoring platform. This platform allows us to search, understand the OpenGL and OpenCL supportive features for each device. And for some certain stages or scenarios, such as shooting, the capturing, we can use different models with different algorithms of different compatibilities, so that more higher end devices could use a better and more complicated algorithm when doing video shootings. The third thing is a whitelist, because we do see some crashes and it's hard for us to solve those problems with softwares. In some devices with gaming modes, they haven't actually designed it well and tested, and once OpenCL is turned on, it crashes. So we use a whitelist. If we found those issues with certain types of devices, we put them into our blacklist, so that with these three ways, we can basically address the challenges of compatibility. And then the third one, stability. We also have three phases of work to improve our application's stability. The first one is our automated tests. We have the tests doing that on our device cluster. Of course, every app developer would do this. And the second thing I'd like to mention about is our online scene regression. auto tests are done after optimizing the engineering, and then the regression is done before launching. But after launching, we also do the online anomaly attribution to avoid big issues entering the launch, the package, and also we do that grayscale verification. For example, 1 or 2% of the users, we give them the latest updates, and based upon their feedback, we make the decision whether to scale that grayscale updates to all of our users. And the third one, as I said, the online anomaly attribution system. This includes automatic monitoring and the crash snapshot reporting and stack reporting, the log reporting, the log management, and multidimensional data analysis, which can help us to fastly locate and identify the crash insights of our users' devices, and so that our developers could improve and solve the issues faster. And here I'd like to mention about our solutions for deployment efficiency from three phases. In algorithm design for NN, we have a code conversion tools and also a trading platform, which includes models, quantifications, etc. And we also provide a algorithm hub platform. And our business partners can have access to this algorithm hub platform to see what algorithms are already supported, avoiding repeatedly inventing the wheels. And many of our algorithms developers have passive backgrounds, but when making the deployment, we use the native type. That's why we also have provided from Python to C++, the code conversion tools, which solves the problem of making that conversion between different coding languages. And for engineering optimization, we have a byte-NN, a front-end engine. The algorithms have been optimized already, and we do also have a fastCL, a high-performance accelerating engine to solve the issues outside of the NN, including the high-performance heterogeneous computation acceleration architecture. The third thing here is our performance tuning tools. Our logo search algorithm is one of that, and we have automated the tests to make sure the entire process keeps on working efficiently. And when doing online deployment, we have other device scoring platforms and other systems of this kind to make sure our launch would be smooth and without a hitch. Other parts include model management and also a plugin platform. And our solution right now is like this. For example, IMG Imagination also has some of their capabilities for VPU, but for that part, it might be cannot be used on a Qualcomm or MTK smartphones. It's not needed and it's not usable. So we use that as a plugin to solve the problem of increased package, because we know the bigger the APK file is or the installation package is, the less willingness will be for the users to download and install it. So we use a plugin platforms to solve that issue. And we have an A/B test platform which can be making it more convenient for us to do algorithm validation to see what are the benefits that we can do with our technical improvements. And of course, the log system is for us to do debugs. Now, our fourth part, future outlook. In this part, I'm going to mention about our future works. We're going to continue with our enhancement of our cross-platform and high-performance computing engine, including byte-NN and fastCL. And we're going to continue to expand our business and the technical scope so that our high-performance computing engine and accelerator could not only serve more for us ourselves, but also look for opportunities of being used by our external partners. And continue, we will to pay attention to the hardware technology, especially computing technology updates, to make sure our high performance computing engine is still top of its kind. And we will continue to have a close cooperative relationship with the community. We've been doing something. We had done something much challenging in the past together with them, and we hope to keep this going on so that also expand the partner pool of ours to collaborate with more hardware vendors because our high performance computing engine is highly dependent on the hardware. And then also, we wish to have more events like today to have interaction with the community so that with our ByteDance experiences on the mobile end, we can help to build the community better together with all of you. And then before I come, when preparing the slides, I have collected some suggestions for the community. Those suggestions are related to our real practices. I selected some of them. The first one is we want better interface and performance compatibility for different compute framework versions because with fragmentations existing, the complexity is much higher for app developers. And we want higher extensions, better extensions specifically designed for computing, such as frequency tuning or memory shares and between different computing platforms. And also for the common cases for computing, we also want some optimizations. Well, due to time limitations, I'm not going to mention the details about that. And another thing is AutoCode Chain. Actually, one project is already available there, and we want it to be more actively supported. Next, the hardware features, so we can have more richer reference materials from the mobile GPU vendors for computing regarding hardware features, just like the hardware vendors did, so that it would make our life much easier from app developers. Thank you very much.